Welcome back to the Deep Dive. Today we are tackling a paradox that sits right at the heart of modern enterprise tech. It's something that, if you work in this space, you've probably felt it, even if you haven't put a name to it. It's this tension between the incredibly sophisticated systems we build and, well, our ability to actually understand them.
It's the classic what versus how problem, and honestly, it's just getting worse.
Exactly. I mean, think about it. For 20 years, enterprise architecture has been completely obsessed with the what. We have these incredible diagrams showing what the infrastructure looks like, what applications are deployed, and what connects to what. You walk into any major company, a bank, a retailer, they can show you this beautiful, perfect map of where their workloads run.
But then you ask a different kind of question. You ask, how does this specific business rule actually flow through the system under these conditions? And suddenly that map is useless?
Right. You ask, okay, what happens to this customer's data if transaction X fails at step 3?
Yeah.
And all of a sudden, the diagrams disappear. You're left with manual digging, reading code, or trying to find that one person who's been there for 10 years.
And hoping they haven't retired. Poor Dave. It's always a Dave, isn't it? The keeper of the tribal knowledge.
It is always Dave. But relying on Dave, that's not a strategy. And that's what we're really digging into today. We're looking at this massive blind spot. We've spent decades building layers to manage the existence of systems, but not the understanding of them.
Which brings us to the topic of today's deep dive, the system intelligence layer.
We're drawing from some really fascinating insights on this shift from Codora. And the mission today is to explore this new architectural primitive. We want to figure out how enterprises can stop modernizing their technology faster than they can actually understand it.
And that phrase right there, modernizing faster than they can understand it, that is the whole crux of the issue. We're building Ferraris, but we've lost the manual, and we're driving them at 200 miles per hour in the dark.
So let's unpack this. Before we even get into what this system intelligence layer actually is, we should probably do a bit of a forensic analysis. How did we get into this mess? Why is this gap even there in the first place?
Well, to understand that, you really have to look at the history of architectural layers. If you look back over the last couple of decades, every single time we hit a complexity wall, we just added another layer to abstract it away.
The classic move in computer science.
It is. Any problem can be solved with another layer of indirection.
So give us the rundown. How did the layers stack up?
Okay, so start at the bottom. First, you had the infrastructure layer. We had to abstract the hardware, right, for portability. We didn't want to care about the physical server or the spinning disk anymore.
Right, virtualization, and then, of course, the cloud.
Exactly. Then on top of that, the application layer. We needed to standardize how we build and deploy logic think containers, Kubernetes. We abstracted the deployment so developers could just ship code. Then, naturally, the integration layer to connect all these new boundaries, APIs, service meshes.
And more recently, we've seen this massive boom in observability.
Yes. Observability gave us signals. It tells us if the system is healthy, if it's slow, if it's up or down. But here's the limitation, and it's a big one. None of those layers, not a single one, was ever designed to preserve understanding.
They optimize execution, not comprehension.
Precisely. They're all designed to make the system run efficiently, not to make the system explainable to a human being. And we're now at this inflection point. We've got cloud-native services, huge API ecosystems, AI-driven automation. The systems are changing continuously, and the complexity is just outpacing human cognition.
So just like we needed to abstract away hardware because it get too complex, we now need to abstract behavioral knowledge.
That is the argument. We need a consistent way to see how systems function, totally independent of the underlying tech choices. Because right now, understanding system behavior is this manual, fragile exercise. It's all tribal knowledge. And tribal knowledge just doesn't scale.
Okay, so that's the why. We are drowning in complexity and our old maps just don't work. So let's talk about the solution, the system intelligence layer. Now, I want to be really clear here because this can sound like, buzzword soup. Is this just really good documentation?
Of course. That's always the first question, isn't it? And no, it is definitely not just documentation.
Why not?
Because documentation is static. It describes intent. It describes what the architect thought was going to happen when they designed the system 3 years ago.
Or maybe 3 weeks ago.
Right. The moment you write that document, it starts to rot. The code changes, configs change, but the wiki page stays the same. A system intelligence layer, on the other hand, is living. It describes reality. It captures observed, validated behavior as it exists right now.
Okay, so it's not docs. What about observability? You mentioned that. If I have a dashboard full of green lights and graphs,
Yep.
isn't that intelligent?
This is a subtle but really vital distinction. Observability, your metrics, your logs, your traces, that tells you what is happening right now. It's purely operational. It says CPU is high or this request just failed.
It's the check engine light on your car.
Perfect analogy. It tells you the engine is overheating. But it doesn't explain why the system behaves that way across different scenarios. It doesn't tell you, oh, the engine overheats because the coolant valve logic has this weird dependency on a sensor that's failing. It doesn't capture the logic, it just captures the output of the logic.
So observability gives you the symptoms, but intelligence gives you the anatomy and physiology.
That's a perfect way to put it.
Hmm.
And the third thing it is not is a static model. We often build models of our software UML diagrams, flowcharts, but they're usually idealized. They're the happy path.
Mm-hmm.
System intelligence is grounded in the actual execution paths, how the logic really executes, how data actually moves, and how exceptions are handled in the messy real world.
Okay, so if it's not those things, let's nail down what it is. Based on the source material from Codora, the core definition is a persistent, machine-readable representation of system behavior.
That phrase, machine readable, is doing a lot of heavy lifting there.
Unpack that for us.
It means the understanding of your system isn't locked in a PDF or inside someone's head. It's data. It encodes the logic, the dependency chains, the data movements into a format that software can actually query.
And maybe the most important feature mentioned is that it's continuously updated.
Yes. As code changes, as you add a new integration, as a regulation shifts, the intelligence layer updates itself. It prevents that decay that makes traditional documentation useless within a month of writing it.
This all sounds great for, a brand new shiny startup building everything from scratch on the latest stack.
Mm-hmm.
But most of the people listening to this, and probably most of the people running the world's economy, are dealing with what we call the hybrid mess.
The brownfield reality.
Exactly. They've got a mainframe from 1990 processing payments, a monolith from 2010 managing customers, and, some microservices they launched last week. Can you really just slap an intelligence layer on top of all that mess?
Actually, this is where this idea becomes most valuable. It has to be technology agnostic. It sits across the entire landscape, not inside one specific tech stack.
It's a bridge.
It's a bridge. Think about the two worlds you just described. On one side, you have legacy mainframes, monoliths. These systems are stable, sure, but they are opaque. They're black boxes. We often don't touch them because we don't remember exactly how the business rules inside them work.
It's the if it ain't broke, don't fix it approach.
Yeah.
Or, more accurately, if it ain't broke, don't even breathe on it.
Exactly. So the intelligence layer can capture those embedded business rules and batch flows, making them explainable without you having to rewrite the whole mainframe. It turns the black box into a glass box.
And for the modern stuff, the microservices.
Well, the problem there isn't opacity, it's fragmentation. You have hundreds of little services. No single person understands the whole picture. The intelligence layer connects the dots. It reveals the end-to-end flow that no single service owner can see on their own.
So it lets you see the forest and the trees.
And crucially, it allows you to modernize without what our sources call premature standardization.
What does that mean?
It means you don't have to force everything onto one platform just to understand it. You don't have to say, okay, we're rewriting the mainframe in Java so we can see how it works. You can support reality as it exists. Messy, hybrid, complicated, while gaining the clarity you need to actually evolve it.
And that leads us to a group of people who are probably desperate for this kind of clarity. Regulated enterprises, banks, healthcare, insurance.
Oh, absolutely. For those regulated industries, lacking this layer isn't just inefficient anymore, it's a massive risk exposure.
Because the regulators are just getting tougher.
It's because regulators are changing how they audit. They don't audit intentions anymore. They don't care what your architecture diagram says you meant to do. They audit behavior. They ask, show me how the data moves. Prove where the controls are enforced. What happens when it fails?
And typically answering those questions is a total nightmare.
It's a fire drill. I've seen it happen. A compliance audit comes up, and suddenly the entire engineering team has to stop working on new features. They spend weeks manually reconstructing narratives, interviewing engineers, piecing together code reviews, just to prove they know how their own system works.
It's reactive, it's stressful, and it must be incredibly expensive.
The intelligence way, as it's outlined, flips this completely. Compliance becomes an operational capability because you have that persistent, machine-readable representation of behavior, data lineage and control logic become verifiable and continuously available.
So you don't have to pause modernization just to pass an audit.
You proceed with confidence. You can demonstrate control, not just infer it. And this is why regulated enterprises are so likely to be the first adopters here. They feel the pain of unknown behavior the most acutely.
This connects directly to the idea of continuous modernization. We usually think of modernization as these big, scary, episodic events. The Big Bang migration. We're going to move everything to the cloud this year. And it usually fails or goes massively over budget.
Big Bang modernization is a symptom of incomplete understanding. You have to pause everything and rediscover the whole system because you don't know what will break if you touch it. It's planning based on fear.
So how does an intelligence layer change that psychology?
Well, when you have it, you can move from episodic to continuous modernization. You can run what we call impact analysis. You can see dependencies and behavioral risks before you ever make a change.
So before I deploy code, I can actually ask the system, hey, who depends on this?
Exactly. If I change this data format in the customer service module, am I going to break the billing report that runs on the mainframe?
That completely changes the day-to-day life of a developer or an architect.
It really does. It means your testing is more targeted because you know the behaviors. Incidents are way easier to diagnose because you understand the execution paths. Change stops being a high-risk event and becomes a steady, manageable process.
I want to talk about the people for a second. We've talked about the tech, but what does this mean for the architects and the platform leaders? If the machine is doing the understanding, are they out of a job?
Not at all. But their metric of success completely changes. It's no longer about who draws the most elegant diagram or who writes the longest piece of documentation.
So what's the new role?
The architect shifts from designing static representations to, and I love this phrase, curating living intelligence. Architecture moves from being a planning function, something you do at the start of a project, to being an operational function. You're ensuring the organization maintains its understanding as the system evolves.
That honestly sounds like a promotion. You're not just drawing maps anymore, you're managing the actual territory.
It is, and for platform leaders, they gain a new control surface. They can finally see how changes propagate across all their services, and it really changes collaboration. Instead of arguing based on tribal memory, well, I think the system works this way, you resolve disagreements with evidence. You just look at the shared intelligence.
It depersonalizes the problem. It's not my opinion versus your opinion.
It's let's look at the data. It creates a shared reality.
Okay, I want to zoom out a bit as we wrap up. We've talked about where we are, but let's look at where we're going. Why is this layer emerging now? Is it just because systems are more complex, or is there something else driving it?
I think it's the bigger picture of architectural evolution. If you connect this to the long-term trend, the next baseline isn't just about more abstraction, it's about explainability.
Systems that explain themselves.
That's the end goal. We need systems that don't just run, but can actually explain their behavior to the people who govern and audit them. And there's a massive catalyst for this that we haven't even touched on yet.
Let me guess. AI.
You really can't escape it. But think about it seriously for a second. We are entering an era where AI co-pilots, agents, will be writing a significant amount of our code.
We're about to see an explosion in the sheer volume of code being produced.
Exactly. If humans are already struggling to understand systems written by other humans, what happens when we have systems being written by machines? The complexity is going to skyrocket.
So if you have AI writing code, you absolutely need a system intelligence layer to verify what that code is actually doing.
It becomes the safety net. You need a layer that can look at that AI-generated logic and map it back to the business intent. Otherwise, you're just building a black box that nobody, not even Dave, can understand.
That is a very sobering thought. We're building the tools to manage the chaos we're just about to create.
Or, to put it more optimistically, we are building the tools to master that complexity.
I like that framing better. So for you, the listener, right now, here's the provocative thought to take away from all this. I want you to imagine your most critical system, the one that keeps the lights on. If it had to explain its behavior right now, without you reading the code, without you calling a meeting, without digging through old wikis, could it?
And if the answer is no, are you really in control of your modernization? Or are you just adding to the complexity?
That's the question. The source material for this deep dive came from CodeAura, who are working on building this exact type of layer to make behavior visible and reusable. It's definitely a space to watch as the lived reality of our systems just gets more complex every single day.
Absolutely. The future belongs to the organizations that can modernize continuously without losing control.
And that starts with intelligence. Thanks for listening to this deep dive. We'll catch you on the next one.
Goodbye, everyone.